Hi, and welcome to deX. Today, we're going to talk about the current state of data engineering, our approach to the industry, and then we're going to have a brief demonstration of our tool. Finally, we're going to talk about our vision for the world of data engineering. Let's start with how data engineering is done today. Have a look at this traditional data architecture used for BI analytics. There might be some deviations from this, but on a high level, this is a good representation of how people build the process flow to supply data to an organization. You start with all your data sources on the left, and then data engineers process that information with a series of operations until it is ready to be extracted and transformed by your BI tool. On the analysis-ready data layer, engineers try to anticipate the organization use cases and manually build great, fast table and make it available to business users. Some companies also operate with parts of the information in a data warehouse, which greatly improves performance, but is also very expensive. It is usually cost prohibitive to have all your data in a data warehouse, so companies choose to load just mission-critical information there. Great, so this architecture worked well until now. But we started seeing some issues caused by the ever-growing volume of information and complexity undergoing this flow. Simply put, we have more information, more people, more sophisticated analysis, and more data compliance requirements. And it's great that BI tools and SQL have become widely popular, but they do not optimize your analysis. They are only just convenient ways of looking at your data, so they are unable to ease the burden on the infrastructure. And this is what happens. Your dashboard response time gets really slow because you have to read and transform a lot of data. So as volume and complexity grows, it gets harder and harder to ensure good performance. We actually heard reports from a few large tech companies that their dashboards for weekly meetings takes more than 2.5 hours to run. This is really bad. And it's not only performance, but also costs. This current way of manipulating data generates a lot of repetitive computing effort because you have to process the same data several times, especially during the BI extract and transformation phase. Users are obviously paying for that. Additionally, you have many tools in your stack, which also end up increasing your total cost of infrastructure. It also requires a lot of people time and coordination to manage this. There's a lot of people, from data engineers to business analysts waiting to get results, that are investing precious time to make this work. And the people doing it are practically your best talent in your organization. We went through all those steps to deliver data to users, but we also need to do the same for changes. You have many copies of your data in your data lake, so every time you need to update a piece of information, you have to make sure all other copies are updated as well. That involves making the change in your processes, testing, loading into production, and communicating the changes. Furthermore, you have to make sure that the change you did not break any other step in your pipeline that you're not even seeing. Lastly, you need your end users to update all their queries and dashboards. This all causes a very slow reaction to change, and change happens all the time. Some companies take weeks to update a column for those reasons, so we see it as a very flawed process. Data engineers spend between 20 and 40% of their time maintaining tables and responding to business complaints about errors and performance. It's so common for them to have dozens of open tickets for data housekeeping, such as updating tables or joining them together. It's a big problem. The data engineer's scope of work is so broad, and they are usually responsible for thousands of tables in a data lake, so they can never finish their to-do list. And if you want to be compliant with GDPR or CCPA, good luck. With so many copies of your information in your storage, it becomes almost impossible to manage data access for everyone and for every piece of information. Using this approach, you also leave room for people to use different data sources for the same business metric or analysis. It is very common to see executives complaining that they got several different numbers for the same metric and unsure on which one is the right one. Finally, the data stack has many different software that optimize your analysis. However, all those changes are exclusive to their environments. According to research, companies have an average of 3.8 BI tools running, so we leave many improvements on the table. In fact, that many different components out there that exacerbates all the problems we talked about before. And remember, those are problems that happen today and will only get worse in the future. So we had an idea. We decided to automate data engineering from a new perspective. deX takes care of creating the best possible table for your analysis and delivers it directly to the user. We simplify your data architecture from this to this. deX is not ingesting or storing the data. Instead, we reorganize your data in storage and create new tables, optimizing for your use cases and using data engineering best practices. We also take care of directing your query to the best table available, so users don't have to worry about where to find the information they need. We are making data self-service a reality. And here's a few advantages of our model. We solve the performance issues because we create the best set of tables for your application. Those tables require the minimum amount of data to be read and the minimum computing efforts to run, delivering performance orders of magnitude higher. We optimize the table's partitioning, joins, data history, and other operations so they end up being lightning fast. This is not something that could be done before because it is a manual effort today, and there are thousands of tables to be optimized in a traditional organization. We make your infrastructure much more efficient because we eliminate all the repetitive computing effort and replace by storage. Again, not something that could be done before because of the sheer number of tables and use cases in an organization. So an additional layer of automation goes a long way. The third advantage we have here is that propagating changes become much easier. Data professionals only have to worry about one layer of clean data to ensure that everyone in the organization is using good information, because that information plugs directly into deX and flows straight to the user and all other queries. And as I said, the data engineer's scope of maintenance is significantly reduced because we automated many steps in her process. This saves a lot of time and money for the organization, as engineers can now focus on ingestion and other projects in their backlog. Data access also gets much easier. Users can restrict access in an earlier stage, in which there are not many copies of the same data. From there, we ensure that no one that doesn't have access privilege can see the information. Finally, since deX takes care of directing your query to a specific table, we can make sure everyone is getting the same information for the same metric, effectively eliminating the data inconsistency problem companies have nowadays. So now, let's see what deX is all about. In this demo, we'll talk about Formula 1. Our dataset has 7 tables that represent basic business entities. They are drivers, results, seasons, races, circuits, constructor results, and constructors. In our architecture, those would be the cleanest data layer. We also described how they relate to each other, as you can see here. This is deX. So, let's assume we want to check the list of countries in which Lewis Hamilton's won more times in the last 5 years. This is what you would do. Great, we got some results. Here we have an auto-generated query, or what you would normally write in a conventional SQL editor. Note that we had to execute 4 joins to obtain the result, because that's the way the relationship in our model go. deX was able to infer the best way to connect the tables for our request, even when the direct relationship between them was not explicitly stated. This is something that other commercial tools cannot do. Now, let's run a second analysis. Let's see how many points Lewis scored per season. Here's our result. Great analysis, but once again, we have the same 3 joins to run this query. We wasted precious computing resources to join tables again. In a more complex analysis, this would certainly damage performance. That's where deX comes into play. Observing those use patterns, deX would materialize a new table to avoid those issues. We made this a manual process for demonstration purposes, but on the final product, this would be done automatically, no human interference needed. Also, the new table would be created using industry best practices and optimal structure. So now we have a new table. Let's see what happens to our analysis. We are keeping the same inputs and running the query. We get to the same results with the same user experience, but this time we don't have any joins. deX knew there was a better way of executing this query, and that's what we did. As a result, this query is now running way more efficiently. And all other analyses that previously required those same joins were optimized as well. Let's have a look at our first query, the one about the countries in which Lewis won more times. As you can see, we are using the new table to reduce joins as well, yielding better performance and good use of resources. Think about this improvement mechanism we did for joins, but expanded for many other aspects of the analysis, such as data partitioning, data history, and mathematical operations. That's how we build the most efficient infrastructure possible. And in the future, deX will be capable of so much more. We are working on a SQL-like interface for people that would rather code than point and click, developing complex metrics capabilities so that users can create metrics from other metrics. We have plans to materialize not only simple joins, but also different formats of tables optimized for cohort analysis and time series. And lastly, automatically apply custom partitioning to further improve performance when dealing with large amounts of data. We at deX are envisioning new ways of working with data. We are pioneers, and we are working to change the world for the better. Specifically, we will make data engineering more scalable and capable of handling the growing volume and complexity of information. We will build a world in which people interact with data in terms of business metrics instead of infrastructure, data lakes, tables, and columns. And finally, we will make our customers truly data-driven, increasing their productivity and delivering better products and services for their customers. We hope you enjoyed learning about deX. Please reach out if you want to know more. Thanks.